Okay. We're going to talk about graphing trig functions. So in order to graph trig functions, we need a unit circle. So we're going to take our unit circle and we're going to graph our trig functions from our unit circle. So first one that we're going to graph is we're going to graph sine. So when we first graph sine, remember that we look around our unit circle and sine is the y-coordinate. So as we go around our unit circle, x is going to be our radian value, and then y is going to be the function at that value. So at 0, sine of 0, my y-coordinate is 0. And then at pi over 6, sine is 1/2. And I'm going to convert that into just a decimal to a tenth so that we can plot them easier. And then at pi over 4, sine is root 2 over 2. So if I put that in my calculator, I get 0.7. Pi over 3, we get root 3 over 2. So 0, if I put that in my calculator, I get 0.9. Sine of pi over 2 is 1. And then sine of 2 pi over 3 is root 3 over 2. So 0.9. 3 pi over 4 is root 2 over 2. So 0.7. 5 pi over 6, we're back to 1/2. So 0.5. At pi, sine is 0. 7 pi over 6, we get negative 1/2. So negative 0.5. 5 pi over 4 is negative root 2 over 2. So negative 0.7. 4 pi over 3 is negative root 3 over 2. So negative 0.9. 3 pi over 2, sine is negative 1. 5 pi over 3, negative root 3 over 2. So negative 0.9. 7 pi over 4, negative root 2 over 2. So negative 0.7. 11 pi over 6 is negative 1/2. So negative 0.5. And 2 pi, I'm back to 0. Okay, so now I'm going to take those decimal approximations and I'm going to plot those points on the top of my graph. All right, so 0, I'm at 0.5. Or 0, I'm at 0. 0.5. 0.7. Pi over 3 is 0.9. Pi over 2 is 1. 2 pi over 3 is 0.9. 3 pi over 4 is 0.7. 5 pi over 6 is 0.5. Pi is 0. 7 pi over 6 is negative 0.5. Negative 0.7. Negative 0.9. Negative 1. Negative 0.9. Negative 0.7. 11 pi over 6 is negative 1/2. And 2 pi, I'm back to 0. Okay, so let's connect those dots in a curve shape. So this is a sine curve. And remember, we could go around that unit circle as many times as we want, so I'm going to put arrows on that guy. Okay, now I'm going to pick a different color so that we can see the difference between the two graphs. So maybe green. All right, so now we're going to graph sine's reciprocal. So sine's reciprocal is cosecant. So we already went around the circle, so we can flip over and do the reciprocal of these guys. Okay, so this guy would be undefined. Maybe like 0 over 1, so when I flip it over, 1 over 0, he's undefined. Okay, 1/2, flip it over is 2. The reciprocal of this guy. So 2 root 2 over 2, the 2's cancel, so this guy is root 2, which a decimal approximation is 1.4. 2 over root 3, so 2 root 3 over 3, put that in my calculator, decimal approximation is 1.2. 1, think about 1 over 1, flip it over is still 1. All right, and then we're flipping that guy over, so 2 root 3 over 3, you should start to see a pattern. 1.2, root 2, so 1.4, 2, anytime we get 0, reciprocal, undefined. All right, then we're on to the negatives. Negative 2, negative root 2, so negative 1.4, 4 pi over 3, negative 2 root 3 over 3, so negative 1.2, 3 pi over 2 is negative 1, 5 pi over 3, negative 2 root 3 over 3, so negative 1.2, negative root 2, so negative 1.4, negative 2, undefined. All right, now let's go sketch in this guy. All right, so undefined. When we have undefined, then we're going to put an asymptote in. Remember, asymptotes are where my graph gets closer and closer to it, but it never touches. All right, and then 2, 1.4, 1.2, 1, 1.2, 1.4, 2, undefined. So an asymptote. Negative 2, negative 1.4, negative 0.2, negative 1, negative 1.2, negative 1.4, negative 2, undefined, so another asymptote. So essentially, the cosecant graph takes my sine graph and just flips him over its highest and its lowest point. Now, at 2 pi, this graph would then repeat again, and you would see the same thing again. So we call this from 0 to 2 pi one cycle because we see a complete set of the graph. After 2 pi, it would repeat again. Okay, so there's 2 of our graphs. All right, now I'm going to do cosine. So back to my purple. Cosine, again, I'm going to go around that unit circle. Now I'm looking at the x-coordinate of my unit circle. So at 0, I'm at 1. At pi over 6, I'm root 3 over 2. So we should see some of the same numbers. So 0.9. Pi over 4, root 2 over 2. So 0.7. Pi over 3 is a half. 0.5. Pi over 2 is 0. 2 pi over 3 is negative 1/2, so negative 0.5. 3 pi over 4 is negative root 2 over 2, so negative 0.7. 5 pi over 6, negative root 3 over 2, so negative 0.9. Pi is negative 1. 7 pi over 6, negative root 3 over 2, so negative 0.9. Negative root 2 over 2, so negative 0.7. 4 pi over 3 is negative 1/2. 3 pi over 2 is 0. 5 pi over 3, back to positives, 1/2. Root 2 over 2. Root 3 over 2. And finally back to 2 pi, which is 1. Okay, now I'm going to take these guys and I'm going to plot them. So 0, I'm at 1, 0.9, 0.7, 0.5, 0, negative 0.5, negative 0.7, negative 0.9, negative 1, negative 0.9, negative 0.7, negative 0.5. 3 pi over 2, I'm back to 0. 1/2, 0.7, 0.9, positive 1. Again, I'm going to give it a curve shape and connect the dots as best I can. I feel like my sine graph was a little bit more accurate. Alright, so there's cosine. And now we're going to do cosine's reciprocal. Come on, buddy. Secant. again, I'm just going to do the reciprocal. So 1 is 1. 2 root 3 over 3. So 1.2. Root 2. So 1.4. 2. Undefined. Notice we're getting undefineds when it's at 0. So if I look at my graph, undefineds are happening when my purple graph crosses the x-axis. All right, negative 2. Negative root 2. So negative 1.4. Negative 2 root 3 over 3. So negative 1.2. Pi is negative 1. Negative 2 root 3 over 3. Negative 1.2. Negative root 2. So negative 1.4. Negative 2. Undefined. Another asymptote. 5 pi over 3 is 2. Root 2. 2 root 3 over 3, so 1.2. And finally back to 1. Okay. Now I'm going to plot these points. Positive 1, 1.2, 1.4, positive 2. Asymptote, right where we thought he'd be, because that's where my purple graph crosses the x-axis. Negative 2, negative 1.4, negative 0.2, negative 1. Negative 1.2, 1.4, negative 2. Again, I'm crossing the x-axis in my purple graph, so I get an asymptote. 5 pi over 3, positive 2, positive 1.4, 1.2, positive 1. So this guy does this. Oops, the doodles. This one looks like a mouth to me. And again, they're flipping over. The high point of my purple graph, the cosine graph, is my low point of my green graph. And again, the low point down here at the bottom at negative 1 is the high point of my green graph, right there. All right, we've got 2 down, 4 down, 2 to go. That's really what I meant to say. All right, the last one is a little bit trickier. So tangent, remember tangent on my unit circle is sine divided by cosine, or in essence, my y-coordinate divided by my x-coordinate. Okay, so we have to do a little bit of work sometimes. So tangent, 0 over 1, so that guy's 0. Pi over 6, I'm going to write some of these first ones down. All right, so my 2's are going to cancel. So I have 1/2 divided by root 3 over 2. 2's are going to cancel, so I get 1 over root 3, and then rationalize, so I root 3 over 3. And root 3 as a decimal is 0.6. Okay, pi over 4. That's root 2 over 2 over root 2 over 2. So that guy's 1. All right, now, pi over 3, it's the same ordered pairs, but he's going the opposite direction. So root 3 over 2 over 1 over 2. So that guy's just root 3. And root 3 as a decimal is 1.7. All right, pi over 2. That guy's undefined. All right. 2 pi over 3, that's this guy again, but negative. So he's negative root 3. So negative 1.7. 3 pi over 4. 3 pi over 4, one's positive, one's negative. So any of those pi over 4s, we're going to get a value of 1. Okay. 5 pi over 6 would be 1/2 over that root 2 over 3. So that's this guy again. So I get root 3 over 3 negative. So he's negative 0.6. pi, 0 over negative 1, so 0. 7 pi over 6, that's negative 1/2 over a negative root 3 over 2. So those are both positive, so I'm going to get a root 3 over 3, so 0.6. 5 pi over 4, they're both negative. So negative root 2 over 2 over negative root 2 over 2, so a positive 1. 4 pi over 3 is a negative root 3 over 2 over 1/2. So this guy, or negative 1/2, so use positive root 3. So positive 1.7. 3 pi over 2 is negative 1 divided by 0, so undefined. This guy, 5 pi over 3, is negative root 3 over 2 over 1 over 2, so negative root 3, so negative 1.7. 7 pi over 4, negative root 2 over a positive root 2 over 2, so negative 1. 11 pi over 6 is negative 1/2 over root 3 over 2, so negative root 3 over 3, so negative 0.6. And then 2 pi, we're back to 0. All right, let's plot these points. So 0, I'm at 0. Pi over 6, I'm at 0.6. Pi over 4, I'm at 1. 1.7. Undefined. So this is the first time we've gotten undefineds in our first one, but undefined, we're just going to graph an asymptote at pi over 2. Negative 1.7. Negative 1. Negative 0.6. 0 at pi. 0.6. 1. 1.7. 3 pi over 2 is undefined. 5 pi over 3 is negative 1.7. Negative 1. Negative 0.6. And back to 0. Okay, now this guy's funky because remember these are asymptotes, so they're going to get closer and closer and closer to it. So this guy kind of curves up a little bit like this, and then he goes like that. So he curves up through the middle and kind of like that. So again, kind of something like this. Notice that this guy starts over again. So we actually see 2 cycles here. The first cycle we see is from 0 to pi. Okay, that's where it starts back over. It starts back over here at pi, and then we see the same part of the graph from pi. I'm going to try to erase that yellow line. There we go. So it starts back over at pi, and we actually see 2 cycles here when we look at tangent. Okay. Cotangent's a little bit easier. Instead of using, let's just do the reciprocals again for this guy. So cotangent. So cotangent of 0. Remember when we had a 0 on the left, then my reciprocal is going to be undefined. Which also makes sense because on my graph, my purple graph is at 0. All right, when I flip this guy over, so I'm going to do the reciprocal of that. I get 3 root 3 over 3. 3's are going to cancel, so this guy is root 3. Decimal approximation of the root 3 is that 1.7. 1 flip over 1, he's still 1. All right, reciprocal of that guy, so root 3 over 3. Notice we're seeing the same numbers. So root 3 over 3 is 0.6. Undefined, when we flip over undefined, we get 0 over 1, so that guy's 0. So the reciprocal of undefined is 0. All right, root 3, negative root 3, so that guy's going to be negative root 3 over 3, so negative 0.6, negative 1 for 3 pi over 4, negative root 3, so negative 1.7, reciprocal of 0 is undefined at pi, root 3, 1.7, 1, root 3 over 3, so 0.6. Notice it's repeating from the top. 0, negative root 3 over 3, so negative 0.6, negative 1, negative root 3. Oh, I missed a negative up there. And 2 pi and back to undefined. All right, here we go. Let's plot these points. So undefined, I did that first one already. Here's an asymptote. 1.7, 1.6, 0, negative 0.6, negative 1, negative 1.7, asymptote. At pi, 1.7, 1.6, 0, negative 0.6, negative 1, negative 1.7, back to asymptote. Again, we're seeing 2 cycles, so this guy is going to repeat. And when my purple graph's at 0, I get an asymptote. When my purple graph has an asymptote, my green graph has an asymptote, or my green graph is at 0. All right, and this guy looks in the same. He's just going the opposite direction. And I missed all of those dots. So here we go. Kind of looks like DNA a little bit. Okay, so we've graphed all 6 of the trig functions. You kind of need to know what their general shape is. A few little helpful hints that I like to remember. Tangent has an A in the middle, so he's going to have an asymptote in the middle. Cotangent has an O in the middle. Think about it being a 0, and he's 0 in the middle of his graph. Okay, so now let's talk about these things and write some definitions down. So, what the heck is an amplitude? It says if the greatest value of y is capital M and the smallest value is lowercase m, then A, we talk about capital A being amplitude, is 1/2 the absolute value of capital M minus lowercase m. Okay? All right, so let's go look at a graph and see what that means. Okay, so maybe I'll go orange. So if I go back up to my very first graph, my sine graph. So the biggest value that my sine graph gets is positive 1. The smallest value that my y value gets is negative 1. So if I talk about the amplitude, I would take 1/2 of 1 minus a negative 1. Okay, well, 1 minus a negative 1 gives me plus 1. So the amplitude is 1/2 the absolute value of 2. Well, the absolute value of 2 is 2, so 1/2 times 2 is 1. So the amplitude of this graph is just 1. So think about the amplitude. If I cut it in half, this is my amplitude. Okay, this is my amplitude. If you think about this, the x-axis being my center line, halfway up would be my amplitude. Okay, well, does cosecant have a maximum value? Well, no. My green graph, my cosecant graph, goes on to positive infinity, and its smallest value goes on to negative infinity. So sine is the only one that has an amplitude here. Okay, when we look at the next graph, the biggest value of my cosine graph is 1, and the smallest value is negative 1. So my amplitude for cosine is 1, but when I look at my green secant graph, he doesn't have a max value, and he doesn't have a minimum value because it goes on forever to positive infinity and to negative infinity. So secant doesn't have an amplitude either. Okay, when I look at tangent, the purple graph, Tangent doesn't have a maximum value. He goes on forever to positive infinity up here. And he goes on to negative infinity down here at 2 pi over 3. So it doesn't have a maximum value or a minimum value. Same thing with my green cotangent graph. He's positive infinity up here and negative infinity down here. So he doesn't have a max value and a minimum value. So amplitude is only for cosine and sine. Okay. The period is the positive value when the graph returns to its starting point. Okay, so if I go back and look at my graphs again, go to red this time. Here I'm at 0. I get back to 0 at pi, but that's not when I'm starting back over. My graph starts back over at 2 pi. So when you can see a full cycle and it starts back over, this is my period. Okay, same thing. My graph for cosecant would start back over at 2 pi. So for cosine, I'm starting at the top. I get back up to positive 1 at 2 pi. So there's my period. And again, with my secant graph, that's when it starts back over as well. And back up to the point where it starts back over. All right, now, tangent and cotangent are a little bit trickier to see. So if you look at cotangent first. Cotangent starts over at pi over 6. At pi, we have a second asymptote, and that's when this guy starts back over. So my period for tangent and cotangent for one cycle is usually pi. So at 2 pi, I see a full another cycle. And again, that's where tangent starts back over. So he starts at 0 and goes up, starts at 0 and goes back up. So for tangent and cotangent, the period for those two graphs is pi. All right, we know what the domains are. The domains are the real number value for x, right? We talk about the domain, we're talking about the x value. The range is the real number value for y. Asymptotes, that's where we get where they got closer and closer to and they never touched. That's when our functions are undefined for our y values. All right, an even function, we talked about this in the last unit, but an even function says f of negative x is equal to f of positive x. And it also means it's symmetric about the y-axis. Okay, we talked about that being cosine. So the cosine of negative theta is equal to the cosine of positive theta. When we look at the graph of cosine, here's my cosine graph, he's symmetric about the y-axis. So if I fold this guy on the y-axis, my graph would repeat over here. So my cosine function is an even function, which also means that secant's an even function. Okay, odd functions. F of negative x equals negative f of x. It's symmetric about the origin. We talked about that in terms of sine. So the sine of negative theta is equal to the negative sine of theta. Remember the sign, S-I-G-N, matters to sine, S-I-N-E. So when we go look at those graphs, Okay, here's the origin. He's symmetric about the origin, and you got to think about it shooting it through. So my graph repeats down here this way, so that makes it symmetric about the origin. Same thing with tangent and cotangent. This guy, again, think about shooting him through, goes down there. Okay, so he's symmetric about the origin. So tangent and cotangent are odd functions. Okay, now we're going to use our tables, and we're going to answer some questions. So you're going to look at your tables, and to save you from scrolling, well, maybe I'll do it. It says, using your tables, find all the values of x between 0 and 2 pi. So that means it wants it in radians for what the sine is of x is 1/2. Okay, so I'm going to look at my tables, and I want to know when sine is 1/2. Well, sine is 1/2 there at pi over 6 and at 5 pi over 6. Okay, then it says, using your tables, find all the values of x between 0 and 2 pi for which the cosine is equal to a negative 1/2. Okay, negative 1/2. We want cosines. I'm going to go to my cosine graph. Negative 1/2 right there at 2 pi over 3 and at 4 pi over 3. So, can you sketch the graph of a basic trig function? Yeah, we just did it based upon our unit circle. All right, which trig functions have a defined amplitude? The only two that have a defined amplitude are sine and cosine. The rest of them do not. Which trig functions have asymptotes? All of them but sine and cosine. So that would be cosecant, secant, tangent, and cotangent. Which trig functions have a period of 2 pi? Everything but tangent and cotangent. So sine, reciprocal cosecant, cosine, and his reciprocal secant. And then finally, which trig functions have a period of pi? That would be tangent and cotangent.